a Cartesian plot. And a Cartesian plot refers to this fellow René Descartes, who was a Frenchman who put together a set of rules about how to make a visual representation of a relationship, or in particular a functional relationship. And this is what he said. He said, well, you're going to need two, what I'm going to call axes, and they're going to be at right angles to each other, and this axis is going to be scaled for the input. So whatever the input is, that's going to go scale along here, and this axis is going to be scaled out for the output. Okay? And then you'll draw a picture, a line, a curve on this graph that represents the relationship between any input and any output. So for example, if I just drew a curve like this, then I'd be able to say, if the input was this value for the relationship, the output was this one. If the input was this, the output was this. If the input was, for example, this one, the output was this one. Many of you have seen the Cartesian graph before, you've used it before, but we're just trying to be very specific about how it was developed and how it's properly used. So your Cartesian graph typically needs a scale on it, 0 usually over here to 10, for example, 0 to 100 over here, maybe, who knows. Okay? So that's the idea. You need a scale, you need units for each scale. The input is measured out along the horizontal, the output is measured along the vertical. And you've got to follow those rules because that's the way everybody's learned it. And if you don't follow those rules, then you'll not only confuse yourself, but you'll confuse everybody else who you're trying to communicate with. So let's take a look at our specific example, the one, remember, of time versus grade. So it turns out, because both my scales were starting with 0, what I'm doing is essentially only looking at this part of the Cartesian graph. So when you see my graph here, there isn't these parts over here, and that's real typical. A lot of relationships don't have any negative values that are over here or down here in them. Okay? So remember, the input was time, so it went on the horizontal, time in hours. And on the vertical, we went from 0 to 100, and that's your score and points. Okay? Now here comes the interesting part. In the previous part 3, you said, or we said, the more I study, the better grade I get. But here we can give an indication of how we feel about how that happens. So I'm going to give you my idea. You probably have your idea. If we did a little research, we would come up with more information about how this works for not only individual people, but for individual tests and people in general. So here's my idea. For example, I'm going to put a score of 30 here. And what I'm going to say is, in this particular test that I'm thinking about, if you don't study at all, you get a 30%. Okay? But the way I'm going to think about it is, if I study a little bit, I don't get much return, right? But as I finally get into a few hours, then things kind of speed up and I get more for each additional hour that I put in. Okay? And then, at some point, I'm going to reach something that we call diminishing returns. In other words, as I study more, the benefit I get kind of slows down. So here I am, and I'm going to draw it out like that. Of course, I can't get better than 100, so I'm never going to let that cross 100. Okay? So here's my idea of what it would be like to have a relationship between how long I study and what grade I want, or what grade I'm going to get. And it turns out that this curve that I've drawn is referred to as a logistic curve. A logistic curve. So, for example, what if I had an easy test? If I had an easy test, it might look like this. Or if I had an easy test, it could turn out that the initial score starts a lot higher. You don't have to put in much time before you immediately go to an A. What if I had a really hard test? It might start down here, where you get a really low score if you don't study at all, and it might be you put in a lot of time, and even if you put in 15 hours, you still don't even get up to anything that looks like a 90%, for example. So each test might have a different curve. Different people have different curves. Okay? That's how it works. The relationship is not necessarily the same in every circumstance. Okay? Also, I have discussed with students before the idea that, for example, you could put in too much time. What if you study and then it looks like you're getting an A, and then you study too much and you don't get any sleep, and as a result, your grade actually goes down. So there's a possibility the relationship behaves like this. A lot of possibilities. None of them incorrect, just a different circumstance. Okay?